related applications and what are those things and how we have done that, right? I will just brief it because each and every project, if I want to you, will take a long time, basically. So one project will take at least 2 hours, right? So I will just brief what are the problems that we had faced during that project and how we have sorted out all these things I will discuss. Okay. So I believe this presentation I have done around March or April time, I believe, to introduce AI to SIST. Maybe couple of you might have joined that thing. So I would like to go through that again to recover the memory. Then I will go to the projects one by one. So as the current trends we know, there are couple of ways that we can divide, right? So there is a traditional AI method. Traditional AI method means using the machine learning or the CNN based architectures and everything and doing the project. The second one now, the trend is using the large language models or multi-large language model, multi-models, large language models to do the projects, right? So in future, there will be a time the traditional methods would not be needed because the problem over there, they cannot run on edge devices because now the other trend going on over here in the industry is reducing the AI models to work on edge devices. That means you have a small hardware setup without connecting to a multi GPU architecture or hardware system. You have to run the whole AI model in the small system. So that is the edge device. So right now, for particularly, there are multiple edge devices developed. What's one thing is called as Jetson Nano, which have a GPU, and we will be able to run AI models on that thing, a small AI models, right? So when it's come to Raspberry Pi, the model architectures have released Light Tensor, right? So that means you can build up AI models and you can run them in Raspberry Pi as well. While building, we know we have used TensorFlows in certain examples, right? So for the Raspberry Pi, the people have reduced the model complexity and the memory requirement, and they have released a new library called Light Tensor or TensorLite, right? So using that, now many projects have been built up and installed in edge devices. So recently, one of the project in my final year group have introduced a project called SmartFan, right? Where they have used the Raspberry Pi module. We know the table fan. If you take a table fan, so when you want to use the table fan in the rotational mode, so we know the table fan, when you turn it on, it goes to the maximum rotation level all the time. So let's say there are two people located little far away from each other, in within, let's say, 50-60 degree angle, and you want to rotate the fan for make sure both of them get the air flow. So when you turn it on, what will happen? The fan will rotate full, right? Maybe 145 degrees, 160 degrees rotation. So unnecessarily, we are rotating the fan where the place there is no people, right? So this smart fan that they have implemented integrating computer vision and AI part. So first it'll detect the people. They have used a web camera in the fan. It'll detect the people first and it estimates the location of the people and identify the angle between these two people or three people, how many people located. It'll find the two people at the edges and it's identify the angle between these two people, and based on that angle it'll basically rotate the fan. For example, this is the fan. Let's say this is the fan, right? So let's say there are five people located over here. One, two, three, four, five people located here. So what it will do is the web camera will be able to take a photo and it will identify the people first, right? Individually, it will identify the people. And based on the computer vision, we know how to identify the people, faces, and everything. So using YOLO object detection algorithm. So they also have YOLO. So here it will detect the angle between the edge people and the fan will only rotate from this angle to this angle, right? So let's say this guy now moved away. Automatically, the fan will set the angle from here to here because this is the person at the edge. So it'll on real time, maybe with couple of seconds delay, it'll automatically identify the persons located in that area and it'll automatically set the fan rotation. That's all, right? So that is a very good project done by a fourth semester student under my supervision. At the same time, they also have used this fan to set the speed in 3 levels. So if the person is nearby the fan, right? The people are located near to the fan speed will be set to 1. If they are located little bit far away, the fan will be set 2. Even further far away they are set located, the fan speed will be located, set the speed to 3. So now they are using a web camera. How to determine the distance from the fan? So it's not a depth camera. Depth camera means yes, we can use two cameras and we can estimate the depth, how far the person is located. Now in this project, the students has used a fan with web camera, which is 2D, right? Now we need to estimate the distance, how far the person is located from the fan. How far the person is located from the fan. So can you guess how the students have done it? So this is the fan, right? First angle location we know. So other things, there is a person in this location identified, set the fan speed to 1. The person identified in this direction, set the fan speed to 3, 2, and far away, set the fan speed to 3. So then only, you know, this person will get the airflow properly. So now they are using a web camera, right? Fan speed 1, 2, 3. Now this is the web camera they are using. So can you guess how did they have identified the distance? Because web camera is 2D, you cannot identify the distance. Any idea? To remember, we have done face recognition, right? Using OpenCV. So when you upload a face which is very closely taken to a person's face, the box size of the face detection will be larger. If a person is located a little bit far away from the camera, the box size that the person is going to do is little bit slower than the person who is nearby. Then let's say the third person, he is far away from the camera, the face box size detection will be smaller. So we have obtained this thing. A person very closely taken a photo, the face will be larger, right? So in that image, so definitely the box size that the OpenCV is going to draw surrounded by his face is going to be larger. Then this face will be smaller, a little bit far away. If is it even further far away, the box size of the face will be smaller. Because the person face size is smaller, the OpenCVs create a box, the size will be smaller. So what they have done is they have estimated this angle, this distance, cross distance, and they have matched with the distance. So if is it nearby, the size of this one will be really large. If that person is located in the edge, so it will be lesser than this area. So it's they set the range, right? So if this length is in between this range and this range, set the speeds 2. And the range is from this range, set the speed 3. So like that they have estimated. So they were able to identify the distance. They have created a map. Okay, face box detection length versus the actual length. And they have created a thing that was around 90% accuracy. So that was detecting the distance of the person, 90% of accuracy, right? So the practical problem that they have faced is different size of people, right? So I have a bigger face and there is a small kid coming and sitting in front of the fan. He might have the smaller face. So those issues that they have detected to overcome that thing, right now they are working on identifying the faces with the age. First of all, the AI will be able to detect the age of the person, or he's a kid, or he's a teenager, or he's an adult. Based on that, it will identify the age first. So based on the age estimation, then the box will be drawn. If the person is identified as a kid and the box size is this much, then based on that, they are going to estimate the distance. So that's how they are working right now. So these are the things that they have worked in recent projects. Okay. So that is a small computer vision project that we have done recently. And that estimation of this distance is very easier. If you want to use a depth camera, you have to have a high-end computing power. But now they have used only TensorLite and implemented in the Raspberry Pi, which works in real time without loading anything. So that is going to be the future of AI, what I think is. Because now we have also learned during the AI program how to select an LLM, large language model, and how we can optimize the size of the large language models and improve the performance, right? So to do the optimization, we need to do the quantization. So we didn't do the quantization because the Google Colab is not capable of doing the quantization, but we took a quantized model, right? We got a 8-bit model and we did a training which is called as fine tuning on a particular data set, right? Einstein codes and everything. And we tested the model. Yeah, initially the model was not that good. After fine tuning, it was able to pick up certain phrases told by Einstein, right? So that means that is the current trend and the future is going to be. And I'm traveling to Japan November to involve in a project. A Japan company called Techno Horizon has invited us to come to their company. What they want is they wanted an AI model to be installed in their cameras. Right? They manufacture these smart security cameras. Right now, the camera is recording the video, transferring it to the cloud, and they do some sort of AI part over there, not much, right? They wanted to have a complete AI setup, which is identifying the anomalies, which is identifying the objects, which is identifying the faces and recognize and everything. So that kind of thing they want it, but they wanted everything to be run in the camera hardware itself. That means they don't want to connect to the cloud and process and get back. No, they want to run it in the hardware setup itself. So that means they are looking for the edge AI. We call edge AI, right? So that is the trend. So building up AI is now fine. We have learned all of the models that we can learn during these 18 weeks. But those are large scale implementation. The memory of the model after implementation cannot be performed in real time if you import it into an edge device. So now the task, the current trend is going to be installing that models into an edge device. To install the models in the edge device, what we need is we need to reduce the size and parameters of these models that we are building up. Basically, we have to use certain libraries which will not load the Raspberry Pi, Jetson Nano, and other small devices, edge devices, and we need to perform the task. And also, most of the time, there will be LLMs coming in edge devices where you can access the LLM in the edge device. You don't want an internet connection. You don't want anything. Just you have a device. You can talk to the device. It will process in the edge device itself. Right. So those are the current trends and which rule the future. Right. So imagine a company, Techno Horizon, is imagining a hardware setup with AI, which is going to perform all the AI tasks on the edge device without even connecting to an internet and cloud services, right? So that's the thing that they want us to build. So we are traveling to Japan November to initiate that project, right? So that's the current trend, I would say. And let me walk through a couple of other things over here. Let me these slides, I believe most of you guys joined and discuss. So we know what are the trends in healthcare and finance, right? So medical imaging, drug discovery, personalized medicine. So AI is playing a huge role right now over here. So there was a Dubai company, right? And they initiated a project to transfer a doctor doctor's knowledge into AI. That means there is a doctor who is a physiotherapist, right? He do the surgeon, right? Physical, like if any broken bones or anything comes, he treat them. He treat them in. He's a big shot. He treats Ronaldo, big players, right? So elite people. So the problem is he doesn't have time to treat the normal people, but he want to pass his knowledge when he treat the broken knee or the knee surgery will cure within 2 3 months, right? It's miracle. When others do these operation or surgery, it take a longer time. So he has some skills on him and the treatment strategy that he has. So now that need to be transferred into an AI. So earlier that consultants company consulted us. We signed an agreement. Finally, due to certain funding issue, that was hold. But we hope we need to get back. And one more thing, I recently met another guy from an Australia called Atlas Labs. So while discussing, his name is Matty. While discussing over there, he said in UK and USA now they have started implementing AI to identify the recovery process of the person who went through a surgery, right? For example, let's say he's a player, he's a football player, he went through a surgery, and now he is s- recovered perfectly. He seems to be okay. He's doing all the exercises. He can run fast. He can walk fast after the surgery. And the doctor decides, okay, now he can go and play the game. But in some cases, that might be an issue, right? Because nobody have tested whether he can play the game intensively. So therefore, now the US company is taking a step ahead. So after the surgery, they install certain sensor system into the place of the body where the surgery has happened. They monitor the heart rate, they monitor other electrical brain signals, and they monitor the X-ray images. They while he's walking, they take the images and analyze their bone structure using these skeleton analysis that we have done for the posture detection. So all these things are analyzed and the in detail analysis given to the patient. Okay, no, even though he's okay outside, still the inside bones are healing. So if he play a game, he might get injured sooner again. So therefore, don't let him play the game for next 2 months. So this kind of things are going on in medical industry, right? So it's crazy. So not only the medication, medical identification and everything after surgery, right? How the AI is playing the major role in recovery is unbelievable. So now the company started implementing that, right? Then I met another guy from India like last Tuesday. He's a person who came up with a device which is a device with a belt you can install or you can wear it in your heart, like that means on your chest. So it's a belt. You plug that device on that belt and it will be able to monitor your heartbeat, your ECG, your how many breaths you are taking for a minute, your temperature, your SpO2 level, many other parameters, right? So one device, a small, maybe I can say the sensor device size is around 5 centimeter by 2 centimeter, not even five, like 3 centimeter by 2 centimeter, very small device, right? Very small device. So now it's successfully monitoring. It's a monitoring device. These ECG, SpO2, BPM, everything, right? Just you need to wear it outside as a belt. With a belt, you have to wear that sensor, which need to be located near to your heart. That's all outside. It's a very tiny device. Even you wear it and put a T-shirt on top of that, nobody will identify that you are wearing that thing. So that kind of device, right? It's a belt. You wear it as a banian, right? Maybe like in a wear. A small thin belt with a thin device. It can. It's a battery operated one, so it can perform for 6 hours continuously. Then after that, you have to charge it, and you can do that. So this kind of continuous monitoring is important when it's come to elderly people, right? So that monitoring part is done. Now, what he want us to do is, he is requesting help from us is to implement a forecasting system. Means based on these device readings, these ECGs and SpO2, whatever the parameter that device is recording, he want to do a prediction. So predictive analysis. So based on the pattern, past historical data and the current pattern, the AI should identify the anomalies in that thing, and immediately it need to send a request to his personal doctor saying, look at this waveform, this anomaly got detected, right? And based on the pattern, it need to forecast also. So this person might have a heart risk by this thing, this week, next week, or next day. So immediately the personal doctor will be alerted. So that kind of device they are trying to implement. But the important thing he want is, he want the whole AI model to be run in the edge device. So that's the biggest task that we have, right? So everyone is going towards device AI because they don't want to rely on the network, computer, or any other Wi-Fi connection, because Wi-Fi connections are unreliable all the time, right? It can disconnect, connect, and the heart rate monitoring system might lose some things. So therefore, they want to run all the things. So that healthcare is like completely, like AI is changing completely. Detection, and while doing certain treatment, and after the treatment recovery, monitoring, now everything is AI enabled, right? It's going to change the world. So crazy, crazy things are going to happen in the future, right? Because of AI. Where the doctor cannot detect, identify certain things, AI will be able to identify and say. So we might have a device saying, next month you might get a heart attack. So go ahead and admit it in the hospital. So imagine, that is not far away from this time. So it's going to happen. And the finance, many people are working, fraud detection, though these other things went on. The manufacturing, definitely, we need to involve AI, basically the computer vision, right? So to identify the quality of the device manufactured, monitor the performance of the manufactured product, quality assurance, and the machinery's performance inside the factory. Whether the machine is performing up to the 100% accuracy, or the machine is performing up to the level of 90% accuracy, or whether any anomaly is going on. So all these sort of things can be predicted and maintained using these things. The telecommunication in the same way, education definitely is going to be changing. So automated grading, intelligent tutoring system that we already have implemented, personalized learning. I used to see a couple of sessions in TikTok, some advertisements for personalized learning. So they are teaching English through an avatar based on your performance. So you don't want an English teacher? You just go and subscribe that platform. You can talk to that AI. Then the AI will talk back to you, and it'll correct the mistake that you are making while you are talking. So it's a talking partner. While you talk, it teach you. It's a personalized learning platform. It's already implemented. Right? Crazy. And the construction side, yes, recently the same Japan company, what they have implemented, the camera, they wanted to monitor the security aspects are maintained in a construction industry. For example, a person is wearing a helmet or not. If the person is not wearing a helmet, immediately the supervisor should be alerted. This person is missing this safety guard while working over here, and checking the performance, how the person is working effectively, or he's just talking and sitting at a place without working. So all these things they wanted to monitor in a construction site, right? At the same time, they wanted to implement a chatbot over there in a for a supervisor. So let's say a certain risk came in a construction industry. So he wanted to know what are the solutions that he have to take to overcome that issue. At the same time, how in the past these kind of situations were handled. So we were requested to get all the written document in Japanese and fed as a knowledge base into the chatbot. right? Those written documents having the safety issues and the mitigation risks and how it can be overcome, every solution and everything in the document, those are handwritten, right, in Japanese text. So the task is to retrieve all the information from Japanese and we have to give the solution in Japanese because it's for Japan people. So imagine what we have done. So we have implemented, we proposed, we didn't implement it yet. That's project also will be discussed in November. So we uh, proposed a solution using Paddle OCR, right? So first we collect the data set and we take an image under a camera. So all the pages will be taken and the optical character recognition OCR will be deployed and the OCR will be identifying the handwritten characters. And based on the identified characters, we translate back into English. Then we do the chatbot. Then we do a small API transition for Japan to English and English to Japan. Then the person can communicate in Japan, that will be translated into English. Then we have all the Japanese text translated into English. So the traditional chatbot way it will function and finally retrieve the English answer and again go through the Google API or translation APIs to translate from English to Japanese back and provide the answer. So that's a simple thing. So there are plenty of applications in the world, right? People are looking for it. But the key thing that they are now looking for it, where even I am lacking on that knowledge, is edge device AI, right? So we know how to build AI in big machines, do trainings and everything, but we need to perform that in edge device. You can do it in edge device. There is no harm. Even the train model that we have done up to now, you can simply run those stuff in edge devices. But the main problem will arise is the delay. The edge device will take maybe 5 minutes to identify, right, whether that person is wearing a helmet or not. By the time the person will move away from that frame. So that are the risks, right? You can perform even now, but the delay. So to avoid the delay, you have to use a smaller models and optimize your model parameters. Unnecessary layers are not needed. So you have to reduce the size of the parameters that you are going to train. Same time, there are libraries implemented as I told. Even PyTorch, there is a PyTorch version where you can install it in the edge device and run it. So those are the things that's emerging, right? Transportation and electric power. So those are the stuff. So the electric power is the thing that I'm going to discuss in today's thing in detail. So let me open up another presentation. I will go through the basic projects right now, what we have done, and I will take a couple of projects and I will go deep dive into detail and I will tell you how we have done that. Okay. So these are the projects that I have supervised in the past, and currently I'm doing these projects as well. One is non-intrusive load monitoring. So I will explain that in detail in another presentation, right? I will open up. The second project, the secure smart home automation system with speech recognition and power measurement capabilities. So there we have implemented, uh, I think now you have the codes to implement these things. We have learned in this 18-week program, right? We know how to recognize the speech, right? So the speech recognition system you can identify. So what does the smart home automation does is it's an edge device AI. So we have implemented the speech recognition system into a Raspberry Pi, right? Which identify the speech in real time and it process all the information NLP task in real time and it identify all the keywords what we are talking and it's understand what we are talking all in edge device and it's control the devices, turn on the light, turn off the light, okay, what is the power usage up to now from the fridge. So all these details can be gathered from the Raspberry Pi. Raspberry Pi is a small edge device that we use, right? The other one is neural network based pipeline for detection sensor anomalies in battery energy storage system. This is a project that we have implemented and published a couple of papers. All these papers you can find out in Google Scholar. If you have interest, under my name, type my name. There will be a Google Scholar profile will come up. So you can go and read these whole detail about these projects, right? So this other project that we have built is sensor anomaly detection. Sensor anomaly detection means basically all the decisions in the industry that we are making based on sensor inputs. For example, if you want to control a temperature of a furnace or a certain place, so what you do, the temperature sensor will be installed. The temperature sensor will record the um, temperature and it will given the value to the control system. So based on the feedback of the temperature sensor, the control system will decide to turn on the fuel pump or turn off the fuel pump or which level of fuel pump need to be operated. Everything will be determined by the control system. So basically, the sensor plays a major role in any industrial setup, any industrial automation system, because those are the feedback system, feedback places, right? But now the issue is sensor is a device too. So how you trust the data given by the sensor are 100% correct? How you identify? You cannot make sure, right? Therefore, we need to have a system to monitor the data that the sensor is providing, whether that is correct or wrong. So that means we have to monitor the sensor's performance. So we have done earlier, I'll talk about something. There are research implemented in the industries to monitor the performance of the motor, performance of generator, performance of that machine, this machine, and everything. But all these performances are monitored through the sensors. If the sensor is given a fake reading or a faulty reading which is not correct, then the control system or AI system, whatever implemented to do the task, will not perform correctly. So there is a need in the industrial system. Now we need to have an AI system to monitor the sensor performance itself. So basically, we have installed sensors to monitor the device performance, and we have implemented AI models to monitor the device performance. But due to these issues, now we have ended up in a situation where we need an AI system where the sensor need to be monitored, whether the sensor is giving the right data or not. So that is the device that we have implemented over here in this part, right? So there are 6 type of faults that the sensor can make is analyzed over there. And we have performed a lot of research and identified and built up CNN based models to identify the sensor fault. So basically now this is the architecture. Earlier, earlier we this is the control system, this is the Veni. So this is the plant, right? This is the plant and this is the control system. This is the control system, right? This is the plant. The plant is controlled by the control system. Then the output, and the output is sent through a sensor feedback to the control system like this, right? And this is the error. This is the PID controller strategy that we use in the industry, right? If you know control system engineering, you know, you might be familiar with these block diagrams, right? So this is the controller. This is the device that we are monitoring or whatever, or performance or plant, whatever, AC or generator or motor, whatever that can be. And this is the sensor. Now, what we have done here, we have added a part over here, an AI model, right? Where after the sensor, which is going to monitor the sensor performance, right? If the sensor performance is correct only, it will transfer the data to the control system. If the sensor performance is wrong, so if it detected the sensor is not performing according to an accurate scale, it will inform the controller to stop the operation because the sensor feedback system is completely wrong. So in that case, we can avoid unnecessary accidents. So there was an accident in China happened in a battery backup station, right? It's a battery storage system where it's a big energy storage system. So they have multiple lithium ion batteries over there, lithium phosphate ion batteries. So where the energy is stored and everything, there is a SCADA system or monitoring system, which is sensor is installed over there. The control system performs based on the sensor input. At the same time, the engineer can also monitor what is going on. So what happened in China was, so the current sensor gives the normal value, traditional value. The voltage sensor also doesn't have any problem, but all of a sudden the temperature sensor started to raise up. Since the current sensor didn't have any anomalies, the controller didn't do any actions. So it was continuing the operation because there is a threshold to the temperature, right? So the temperature crossed the threshold value, but it was too late to stop the operation. Immediately, the battery bank blasted. So there's a huge damage to that area, and they have lost millions of dollars due to that battery bank damage. So later on, they identified the current sensor was faulty. It was not giving the correct value. Actually, during that issue, the temperature rise, the current value went abnormally high. So due to that reason, the temperature also raised. But the temperature sensor installed to monitor the battery bank input current or the output current is not functioning properly. So due to that, the control system thought it's nothing going wrong, so it didn't take any preventive measures. All of a sudden, it blasted. So to overcome these kind of scenarios, now the factories and every places need to have this setup in the future to monitor the device parameters, preventive maintenance, all these things. We need to install sensors, but to monitor the sensor performance, we need another AI model which need to be installed in parallel to these control loop. And other many other applications that we have done in power industry, monitoring a turbine generator. Basically, we have implemented a system in Kalaniti power plant to monitor the anomaly stage one. I will also walk you through how we have done and everything to do that task little while. And some other projects are microgrid related project to optimization. So earlier we used to do mathematical model, do some traditional standard way of optimization, particle swarm or generic way of optimization to optimize a function. But now we don't want to do it and spend a lot of time. Let the AI do the optimization function. So we have done in multiple AI power optimization process using AI. And the smart traffic monitoring is one of the projects that I have done and published papers. Over there, you can find it out. So which it's monitor the real-time traffic and it controls the signal lights. So in Sri Lanka, we have a problem in morning times. Usually the traffic people come and turn off the signal lights and they manually control that thing because the traffic lights are pre-programmed thing. It cannot adapt to the traffic. What happens? The guy who come and turn off the light and the traffic police manually do the management in the morning and peak hours of evening time, right? So it's really hard for that person, right? How to automate this thing? How we can make the AI to adaptively change the turn on red light time and green light time in real time. So that's a task now. At the same time, we also have a problem. I have seen the ambulance get traffic in a during these peak hours in Sri Lanka, morning hours and evening hours after the office hours, during the school time also, right? Especially in Colombo. So how to overcome these issues of emergency vehicle? Imagine there is a fire truck, there is a fire got off in a big building, the fire truck is running, but it got stuck in a traffic. How to overcome these issues? The red light doesn't know how to overcome. It will continuously turn on. The vehicles will be stuck. It will not do. So how to overcome these issues is only way through AI. So we have implemented and tested and like simulated, and we have shown the concept to the government and every places. And now I don't know what's happened after that. The TLM, Transportation and Logistics Department, also concentrated on this project. Right, in one of the conference, this project won a best paper award. Right. So what it capable of doing is, so it's identify the traffic. So it's count the number of vehicles standing on a line. The cameras will be installed on the traffic light itself. In that pole, we'll be installing the cameras. The cameras will real time monitoring the traffic and it's identify the vehicle. For example, a vehicle over here come around. Give me a second. Vehicle over here came 1 minute earlier and it's staying for a long time. But imagine there are only 5 vehicles in this line, but there are multiple vehicles on the other line. So we cannot keep this guy waiting more than 1 minute because of only five vehicles are in the line. So it need to check that, okay, when this guy came and how long his waiting time was, right? And it set the green light and it knows only five lights are there. Five vehicles are there. So it set the green light until these vehicles are moved away and immediately turned it to the red color. So it's adaptively changed the light. At the same time, we have implemented the system to identify the ambulance and fire trucks. So when the ambulance and the fire truck are identified by the camera YOLO object detection algorithm, immediately it will clear that path. Okay, let's say the ambulance is coming here, right? Ambulance is coming here. Immediately, in this rain, all the lanes will become red and this path will be made clear. So these vehicles will be cleared out, then the ambulance will go freely without staying in the traffic. So these kind of things are implemented in AI things. So this is already there in foreign countries, even US, they have implemented multiple things. I have seen this in US. So when the ambulance or fire truck or whatever the things comes in, they use a communication device. It's not camera. They use a communication device to communicate with the nearby traffic signals. So all the signals become red and one of the flashlights start to flash. So that means we know the lane, one of the lane, the ambulance or some of the thing is going to come. So we take the lane to the right side and keep our vehicle to the right side, further right, and the ambulance will clearly go without stopping and waiting for any vehicle. So that's the system that they have implemented. That is through a different communication line system, wireless communication. Here, what we have implemented is a little different one. Okay. So, and the other thing, power baseline, another project, I will discuss those things in the latest slide. And the cyber attack detection, because these are the patterns. We monitor the patterns of communication links in the power line and we identify the anomalies. We can identify whether it's a power detection attack or not. Even that is capable of doing that in the vehicle. And this is another project I will like to go deep dive. So I will show some slides. And this is the hotel projects and everything. So this is now intensively used by the hotel users in Dubai. So they are very happy with the results that it's providing. The forecasting results, it's more than 85 percentage all the time. But if they have, that is more than 85 percentage of accuracy with past 8 months of data. Crazy, not even 1 year, right? Past 8 months or 10 months of data only they have. Based on that data, we are forecasting up to 85 percentage accuracy. If they have 3 years of data, ideally, this will perform more than 95, 98 percentage. So we are collecting data and we are training it adaptively every time. The model is getting improved every time we are doing the training. And there are some other two researches that I am conducting right now. This is another trend in the robotics environment. So earlier what we do is we integrated these NLP, natural language processing keyword detection task into robotics to understand the human language. Okay, when a person say, hey, there is a predefined sets of keywords, turn left, go straight, turn right. So these kind of things are implemented way back. So when a person is saying, okay, sitting on a wheelchair, imagine, okay, go straight, stop, turn right, stop, go straight, stop. So these kind of keywords based searching algorithms were there in earlier. So they can control the wheelchair or any robot using keywords. So the keywords are detected using natural language processing, NLP. So we have done that chatbot also. Keyword detection based chatbots. Yeah, we have done it, right? So the same approach in the past, the robots were implemented. But now, after the large language model comes in, so no more we don't want to say the keywords. We can say, hey robot, say take me to the kitchen and after picking up this object from kitchen, I want to go to the bedroom. So you just say this in a straightaway stretch as you talk to the your servant. Then the chatbot, these these wheelchair-enabled wheelchair will be able to identify what are the tasks that it need to perform. Everything is now using by large language model, LLMs, right? So it's identify the task, it identify the keywords, it's instruct the robot what to do, and the robot will do the task. So no more keyword identification is there by NLP task. Now it's completely done by LLM. So LLM will do the structured workflow based on our input. So there are researches conducted, and we are also trying to do something. We wanted our robot to say, okay, go to the kitchen and pick an apple and bring it to me. So that's in any language you can tell. So you can say, go to the kitchen and pick an apple and bring it to me. One way you can tell it, hey robot, I want you to pick the apple from the kitchen and bring it to me. So you can tell it in any way that you want, right? So the AI will be able to, the LLM will be able to identify the language, and it will separate what are the keywords and the tasks need to be performed, and it will instruct the robot platform to do the task. So everything is driven by AI. So one step ahead, we are trying to do real-time path optimization using LLM. You know, the multi-language model, multi-LLMs, MLLMs are capable of identifying the objects, capable of identifying the paths, and capable of identifying everything, right? So what we are doing right now, even in a real unknown environment, if you put a robot over there and say, okay, go to that corner and pick the red box and bring it to me. Immediately, the AI will take a camera, will take an image of a room, and the objects in the rooms will be identified, and the AI will look for the blue box or red box, and it will estimate the location from the current point, and it will plan the path through LLM, all done through large language models, and it will do and go there, pick the object and come back. End to end is LLM enabled thing, right? That is one which we are trying to do. So in the future we are going to have robots which are going to be really crazy, right? It can work with human as a friend. You can have a AI robot in your home, so as a talking partner, and the talking partner will match your persona. So we can make the robot to learn how your activities are, what kind of person you are, what are the things that you watch, what are the things that you are interested in. So the AI will change itself to entertain you and give company to you, right? So it can give you some suggestion, it can talk to you, it can crack jokes, it can talk about the things that you are interested in. Going to be crazy, right? So that is one thing. Other thing, this one, quantization and fine tuning of large language model, that is another thing. Right now what we are implementing is to implementing a singular language model. So there is no singular language models available in Sri Lanka. It's not built up so far. Even though the ChatGPT is capable of handling the singular language to a certain extent, but when we have tested in complete complex prompts, that fails. It doesn't understand singular. So what we are trying is, we took a model, large language model. We are doing the training to identify whatever the commands told in singular. So we are training a large language model which can identify singular words and singular communication. So rather than saying go to the kitchen and pick an apple and come back, you can say kitchen kusini apple like a pick karala methane and gila, like you can give singular commands. It will completely understand and do it. Right now we are doing the training. It's not an easy task as we thought. It's killing our time, and the performance is not that good after the training also. But we are trying multiple approaches, right? Because this is going to be in the edge device. What we wanted to do is, we don't want to connect it. This one of the project, this one that we are trying to do, this is connected to the cloud. So it can work on the cloud environment, so the complexity is less. So here the robot, we wanted to run it in the edge device. So it cannot connect to the cloud at all. All the tasks need to be performed in real time in an edge device. So that's another task that we need to optimize and reduce the size, and finally we need to come up with this solution. So we are killing a lot of time over there in that thing. So these are the projects that we have done, doing, and a lot of other industrial projects also involved. For example, we have built up a tool, AI tool right now to automate the test case. That means, like, there is an industry, airline industry. So there are QAs, quality assurance managers, and test engineers. right? So these people, what they do when an error report comes generated by a client or generated by the system automatically, they go through the report. So the report might be around 20 to 30 pages long. So it will have a lot of images. It will have a lot of complaints over there. What they do is they go through the 30 pages and they come up with some test cases. Okay, now these are the issues happen in the real time. So now we need to test these modules are working individually. So do this test and the result should be this one. Do this test and result should be this one. Like that, they create the test cases for the testing engineers. So that takes at least 2 3 days for them to create the test cases based on the document that they get, because they need to go through the links and they need to go through the reports and identify the images and understand the images and everything. It's a tedious task. So we have automated that test case generation. What they need to now do is they need to just upload a PDF into that domain. That's all needed. Immediately, the AI will go analyze the document, take couple of minutes. Finally, it will provide the test cases immediately. Then we can use the test cases to the testing engineers, right? Then the airline company that we are working with requested us to automate the whole thing also, not only generating the test cases, but also do the test automatically and say, okay, these are the results of the testing. So now that's crazy, right? So this is the AI, where the AI is going. So when we show some capabilities, the customer asks, no, no, now you have built it. Thank you. That's amazing. But we want this need to be automated using AI as well, right? We can't say no to a customer. He's a big client, airline client. So what we do, we started implementing fully automating the setup also. So now we did some trial after the test case generation. AI will be able to understand the test cases and automatically do the testing in their website and the system step by step and obtain the output and check with the expected output and create a report. Okay, we have done these many tests automatically and these are the outcomes of this thing. The test cases fails in these scenarios. Here it will generate a report, right? Imagine. So that is under the development. We still did not develop fully, right? So these are the things. So you cannot even imagine where the AI can be included. But in future, everything is going to have AI, right? Even your smart devices, your smart watch, whatever the things, they are going to say AI enabled watch, it will do certain things. But if you deep dive and look at it in a little bit deeper, you might see some anomaly detection, preventive forecasting machine mechanism. On these things are integrated over there. Nothing much. But by Maurice, this LLM, right? So the growth of LLM. So the next GPT is going to be even more powerful and it can do more powerful tasks than that we do right now. So as I told you, right now we are doing a campaign generation for marketing of a product, right? You upload the requirements of the products and what are the product capabilities and features and your marketing budget. That's all you have to do. The AI will take you through end-to-end marketing process automatically. It will request for recommendation and suggestions and clearance of your view. Once you clear and give permission to the AI, okay, go ahead. I don't like this. You have to change this advertisement. You have to change this video. Even the video generation, completely is going to done by AI. It's crazy. Can't even imagine, right? Even I didn't imagine we can do these things with AI, but the projects are happening. World is moving really, really, really fast, right? And in one of the collaborator that I'm working with, they are working on basically automating these end-to-end patenting process. In US, applying for a patent is a real hectic task. So what they wanted to do is they wanted to automate the end-to-end task. So the person comes and tell about his invention, then finally as a chat, right? Finally, that will prepare the law documents and all the patenting application documents, and finally, even it will help to file the patent. So end-to-end process of patenting. Simple. There was a time we thought about it earlier in 2022, 20, when we started initially, we thought about it. But at that time, the capability of AI is not that good to do that task. Now with the GPT-4o release, definitely we can do that stuff without any trouble. So end-to-end automation is completely possible. Okay. Okay. So I'm going to walk you through some of the projects that we have done in the industry and real world application shortly. Give me a second. I can see, right? So this is a project which is accurate prediction of remaining useful lifetime for lithium ion battery cells using deep neural networks. So this is one of the project that we have done in our university. And the good thing is now one of the Nissan service center, they have requested this model to be implemented in their system. So that's a success. We do as a research and the industry comes and they were amazed by the results that this model is doing, predicting, and they wanted this to be installed in the machines, their machines. And we are kind of planning to sign an MOU because we cannot give it for free, right? So, but we want our system to be used by an industrial expert, and based on that expert input, we need to modify the things. Finally, we can go for patent or whatever the things that is applicable, right? So now the no nobody want to explain the issues in the car, right? So we have collaborated with this guy. He's Michael G. Page. He's a professor from University of North Carolina, right? Maryland University. Sorry, Maryland University, and he's actually a big shot in battery research, right? You can see they have almost 60,000 citations. It's a crazy amount of citation. If you are a researcher, these things are kind of addiction. I have only 290 over here, right? So you can imagine how big this guy is, right? So we have done a collaboration with this guy and got the data, and we have started analyzing data. So everyone knows with the issue with the electric versus gasoline. I don't want to go through that. And there are multiple providers, Tesla and BYD. So the electric cars. So when you take so we don't want to go through that. I will just highlight the part over here. So these are the electric thing. So mainly the battery is supporting the driving and it giving the power to the system to drive, right? So, but the problem of battery here is battery degradation, right? We cannot use the battery for lifelong. So there is a lifetime for a battery, right? Nowadays, I went to China last month. We canceled 2 lectures. So during that time, I went to a place called Canadian Solar. They are implementing batteries for energy storage, huge batteries in containers, right? You can ship a container, you can place it in a place where you excessively generate electricity. Then you can store the electricity over there and you can dispatch during the time when you need it, right? So the cool thing that they have mentioned was they are giving 20 years of warranty for a battery. I was like, 20 years of warranty for a battery? That cannot be done because the battery life is usually 3 to 5 years maximum. So how you give 20 years of warranty, right? I met their CEO, CTO, right? So what they have told us is, okay, if we see it, they have measured the lifetime by in terms of charging cycle. So you doesn't care how many years the lifetime of a battery is. But basically what matters is how many times you are charging the battery and discharging the battery. If you are charging the battery one time and discharging it one time per day, then they said they can go for 20 years. So that means 7,000 cycles closely. So charging and discharging cycles 7,000. So that means one time charging, one time discharging per day will keep your battery alive up to 80% accuracy and 20% degradation up to 20 years. That means that's a long time, right? That's the battery technology that we have right now. But when it's come to battery cars, car battery, we cannot have that amount of battery to charge a lot of amount of charge. So where charging capability is limited because of the battery amounts that we are going to keep it inside the car because of the size of the car is matter. So sometimes some people who want to go for long drives, they charge maybe 3 times per day. right? And they are going to charge fast charging. So these are issues in the cars. So when the car degrade, we know we need to the car distance that we traveled earlier with the to the compared to the old new battery. The old battery is going to have a long, less driving range, loss of power and performance, longer charging times, increasing energy costs. A lot of things are going to happen. So how to overcome that, and how we can go for a secondary replacement of a battery? So the lithium ion battery is the thing that we are using in the cars and everything, right? So you can see this is the graph with the cycle count versus the capacity regression. One means is the best battery. So this is one cell I am talking about. When you take one cell and you charge, discharge, charge, discharge, charge, discharge, charge, discharge, charge, discharge. Cycle count means one charging and discharging cycle is one cycle. When it's come to 160th cycle, you can see 100 percentage battery degraded to 70 percentage of the capacity. That's crazy, right? Because that's not that's not good enough, because 180 cycles. So this is the degradation things looks like when it's come to the batteries. Give me a second. Okay. Okay. So this is the way the battery degrades. So now we have implemented a system to identify the remaining useful lifetime of the battery, right? With memory feature. Give me a second. Give me a second, guys. I have to attend this call. Okay. So that's the thing. So what we have done was we have collected, but if you take the Nissan Leaf car or any electric cars available in the market, they have a system where you can estimate the BMS, right? BMS is installed. So you can charge and discharge, and it will have all the capability of the historical data of the battery in the BMS. So why you want to implement an AI system to do that? If the BMS is having all the historical data and it shows what is the battery performance right now, how many remaining cycle is there, we can estimate using the BMS data. But the main issue is if you replace one cell from your battery pack, then no more that data is valid, because completely you because the BMS is from the beginning to end. If you replace the battery, the BMS cannot capture that change. So now our AI model, the battery model, BMS model says fails at that point if you replace a battery. So why we have implemented this AI model? You take any battery, we don't care about the BMS data, whatever the things, we will be able to identify how much remaining useful lifetime is there. It can be used to do these things. So this is important when it's come to the secondary market of the battery. For example, a Nissan car which is driving 90 kilometers with the battery pack, we take the battery because it's degraded, it's not performing well. We take that battery, we install it into a three wheeler, as a secondary market to get the battery lifetime details and identify what are the information from that details and how many remaining life cycles are there from for that battery. We need this model, right? For that task we have done it. So what we have done it, this is our architecture of the AI model. We took an original data from NASA and the Kelsey lab. So we have done the pre-processing, feature engineering and everything, and we have get the charging features and the discharging features. Those are charging current and voltage and temperature while charging, and while discharging current and these things. We need to take out the battery from the car. We need to charge 3 times and discharge 3 times, and we need to record the current, voltage, and the temperature. These are the 3 parameters we look for, and we get the memory features, and we can predict based on this input data the remaining useful life of the battery. So based on these results, we were able to identify, and we have tested certain results. Nissan Leaf 1 battery cells over here, and the BMS system said 32% remaining lifetime of the battery. When we do the battery test in our lab and we tested with our AI model predicted around 2 points. Sorry, yeah, this is the one that we have implemented 30.984, where the BMS system installed in the car says 32%, which is very close because this is 32%, because we also have done 3 times charging and 3 times discharging. So there is a degradation over there close to 31. We also getting 31. So it is 100%, almost 98, 99% accurately detected. So this is the model that we want to know. So when we are going for the used battery second-hand market, without relying on the battery BMS system data, we don't care what the BMS says. We can run this AI model on the charging discharging curves of the battery. Then we will be able to predict what is the charging and discharging current. Based on the charging discharging current input data, we will be able to get this thing, and based on that we can say, okay, so predicted remaining useful lifetime is 30%. Okay, this might be useful for in a motorbike, not for a three-wheeler. So that kind of research that we have done over here, right? And other thing, let me share the second research is non-intrusive load monitoring, right? Let me share that one. Okay. So this is the other one, non-intrusive load monitoring. So here we know the intrusive load monitoring means basically we can monitor the power consumption of individual devices by adding a power monitoring device to each device. So let's say you have 100 devices in a home or a mall or a factory or your office. You have to have 100 smart plugs to monitor your energy consumption of each individual devices. But non-intrusive means you don't install 100 devices. What you do is you install one sensor at the energy meter that is going to record whole power consumption data of all the devices together, and it's going to identify where the device is on, this device is on, where the other device is on, where the light is on, where the microwave is on, where the fridge is on. All this information will be extracted through an AI using non-intrusive load monitoring. So that is the concept. So that means you don't want to install 100 plugs. So all the devices can be identified from the total power consumption data. So what we have done, we have implemented a model, and to use, it's a CNN based model. There are multiple feature extraction. The input data is the power consumption with the time. So these are the model architectures. This is little bit too much if I go into this detail, but if you go in, the basic architecture is the CNN, right? And we have used the LSTM model for the forecasting. So now we recorded the three-phase data. So you can see three phases: orange is one phase, green is one phase, and the blue is other phase. So the blue has some single phase appliances added to one phase. Due to that, this is unbalanced. So now our task is, this is the total power consumption. We need to identify where the other devices are turned on. So we have implemented the AI model. We use WaveNet and CNN architectures and everything. And we were able to successfully identify from the total power consumption and how which device consume how much of power, because we can detect the on and off time and power consumption from this total power consumption pattern. For example, this is the total power consumption top view. You can see the power is around 30,000 watts, right? But here, this is the energy usage of a single phase inverter AC. So we detected accurately there is the place the single phase AC is turned on, and we can estimate the power from this one. And the total power usage is told over here, 4.51255 kilowatt, right? And at the end of the month, you can get energy cable. Okay, your fridge is consumed this much of power. This is the consumption of your AC. This is the consumption of your microwave. All these kind of breakdown can be given, right? So, so you can see this is the washer dryer, right? So you can see this is the total power consumption where 40,000 watts, but this is the places in this total power consumption area. These are the places that we have used the washer dryer. You can see the power pattern, right? The target and prediction. We have the target, that is a blue color one. The prediction is exactly predicting the washer dryer around 98%. So this is for the dishwasher. So these are the places in the total power consumption area. The dishwasher was identified. And this is for microwave. You can see these are the places the microwave activated in the total power consumption area. And this is the place for water pump. And this is the place for fridge. And this is, you can see the fridge is not identified properly because the target is blue color, but the prediction is little bit off, but still it's identified. That's the fridge, right? That's the benefit of this one. So this is for fridge 2. This is for exhaust fan. So you can see the prediction was, target was not that aligned, but still somewhat it says, okay, this is this one. So the washing machine and the inverter type AC completely identified. So we are the first group in the world to integrate the inverter type machines into this system to identify the power consumption in the world with 99.8 for accuracy. You take even MIT to whatever the worst university in the world, Moratowa University is the first and only university have done this research. And we have published the Q1 journal articles and a lot of conference papers on this research, right? Multiple journal articles as well. So this is inverter type AC2. You can see the prediction and the stuff. So these are the stuff. Finally, we were able to achieve this much of accuracy on this research, right? Now this is a current trend, but there are certain limitations. So how we are going to record the data initially, because we have to train the model to identify the fridge 1, fridge 2 means we need the data of the fridge 1 and fridge 2 too to train the model to identify the fridge 2 and fridge 1 from the total power consumption. So that's the question right now that we are trying to solve. There are certain researches going on. We are trying to optimize this thing to answer those questions. We'll see in the future how it's going to go. But with the AI enhancement, every time the GPT is doing the training, every day the AI is, there are a lot of models released in the world. So we will be able to generalize a model which will be able to detect any type of fridge. I believe not in long run. In couple of years, we will be able to solve this problem with the newly released model. So this is another research that we do, that is non-intrusive load monitoring. Let me open up the other one, that is the one which is the sensor anomaly detection. Okay, so this is the sensor anomaly I talked about. So here, these are the introduction, the battery bank issues and everything. So these are the 6 type of faults that is possible caused by a sensor. One is freeze fault. It stopped giving the value. It stuck at a value. And this is the bias fault. So the actual value is this one. It's little bit biased and giving a higher value. And spike fault. All of a sudden, it give a random value, right? And this is drift fault, mean it's just keep on growing in a drift way. And precision degradation fault means this is the original versus dot is the faulty. So these are the 6 type, 1, 2, 3, 4, 5 type of faults that can happen in a sensor commonly. So to overcome that thing, we have built up a CNN model. Finally, we were able to detect these. Give me a second. I'll go to the results. What we have done here, it's a moving window type. So what we take every five, one, two, three, four data, window moving, and we analyze for any anomalies. Right? The moving window is going to analyze the data like this. Right? Every four samples, we are going to check the data, and one by one, we are going to do. It's like a convolution. We have done a convolution using a kernel sliding the window. Similarly, we took a sliding window approach to overcome these issues. Right? So when you take that one, so these are the data that we got. We got data, we created the fault, and we recorded the data, and we test the model. So I would like to go to the thing. This is the neural network based architecture that we have done, right? Supervised deep neural 1, 300 nodes input layer, 3 hidden layers, and output layer 6, right? And the LSTM is a recurrent neural network architecture that we have implemented into that. Finally, we were able to get this kind of results. Okay, I want to show that table that we have implemented. So you can see, so the typical different type of RNN models were analyzed with different type of data set. So this is the accuracy, one mean 100%. So these faults were detected 100% accurately. The spike fault and the PD fault are the thing that we had little bit less accuracy due to the nature of the fault, but most of the time it was identified 100%. So based on the accuracy and everything, we have selected LSTM model. Basically, when it's come to detection, forecasting and stuff, LSTM model is a better thing, right? So that's the one that we have implemented. So those are the things that we are doing, and plenty of researches are going on in current in our company and where I do the consultancy firms and everything. Unbelievable projects, right? So that's the industrial applications, and you are working on different industries. You can think about something that you are daily struggling to do that task every day. Simply, you can use AI to automate that task, right? So think in this direction. So that's all I have for today. And I have an appointment at 11. I have to go. So that's what I just requested this to be online. Any question that I'm more than happy to answer?
So, one question I'm having.
Yeah.
So, when we are using these kind of models in the industrial applications, especially when it's come to commercial things, is it okay to use those kind of things like normally PyTorch things and other OCR tools kind of things?
Yes. Yes, you can. You can definitely. Because you are going to
Do we
host
have
it
to
in your
pay?
secure environment.
Yes, in our own environments. So, do we
Yeah.
have to pay any license and other things, or will it
No,
come
no, no,
under?
no. Those are open, eh? So those are open in the
Okay,
Python libraries. You don't want to buy any license.
okay. When it's come to legal considerations, is there any like data leakage prevention issues,
Yes,
privacy?
yes, yes, yes. If you are using the GPT, there is a risk.
Okay, anything other than in a closed environment, then there is no.
Yeah, yeah. There is no data leakage. It's going to be hosted in your own model. But what we have done in industry when we want to use the GPT based models, right? What we
Mhm.
have done is we have hosted them. The GPT also, we can host the GPT in Azure. There's a
Uh-huh.
little bit charge. You can host the GPT in Azure. You don't want to go to the OpenAI. You host your GPT in Azure and you get the API through the Azure and use that API key to do the task. So in that case, the data linkage to OpenAI is completely eliminated.
Oh, that sounds
But
good.
yeah, but it's a little bit costly too. But if the client is worried about certain things, then definitely you can propose this option. Okay, hosting the LLMs in your own Azure. That is possible. We I have done a model in Azure APT. That test case generation is basically hosted in GPT. GPT is hosted in Azure. Try to build exe file using PyInstaller and give me an error regarding dependency error. Are there any that that's CS exe means what exe? Is a trained final model? Malindu? Okay. So which library that you are using? Are you using a PyTorch or a TensorFlow or Padlos? Yeah. So after, but no, you can just use pip install Padlos. Yeah. That's a simple installation part. So I just go ahead and type pip install Padlos or something, then ask ChatGPT, execute the code over there. Then as a dependency, it will be installed over there. You don't want to download the exe at all. Python 10.1 is having that one inbuilt in that thing. Connect to the internet and do that. Paddle info missing. Maybe you can install a particular version of a Paddleosia. Maybe you are trying to install an older version. So check for the version, then install. Even yesterday I worked with Paddleosia. It didn't give me any error. Try it out. If you're facing anything, we can connect individually and we can figure it out. Okay. Yeah. Check for the which version is that.
So since Malindu asks something related to the final output releases, so
Yeah.
when it comes to releasing a AI model into a real environment, do
Hmm.
can we release it into a Windows environment rather than putting it into a Linux kind of thing, like a Python environment?
Yeah. What I observed is, yeah, you can do it into any environment, any OS, it doesn't matter. So
Mhm.
in my observation, Linux is faster than Windows because Windows VM is always slower due to other loading, other applications loading, right? But if you are hosting it in a Linux server, that's going to be speeding up the process, the complexity is less. So we worked with the client and the client, we implemented the model in Linux and it's worked completely fine. But this client wanted to install it into a computer CS server, right? That Windows server. Then VM, when we tried to install it, it gave a hard time because it slowed down. The training got stuck and interrupted at the middle. So these issues came. So finally, we were able to sort them out. But however, there was an issue in that slow. It's performed slow when it's come to Windows. So in my experience, I prefer Linux.
Okay. Because why we have completed that OCR model which we are
Okay,
trying to
cool,
do.
cool.
Yes, we have got a 98% accuracy.
Oh,
So,
wonderful. That's wonderful. Cool. Nice to hear that it's coming into the practical implementations. Good.
yeah.
Let me know if you need any helps, okay?
Okay, sure, sir. Thank you, sir.
Yeah. Okay then. Yeah, Para. You are muted. I was calling you for a long time at the beginning.
What happened actually, my this headphone was connected, but I was not using it. So
Okay,
you could
okay,
have
okay.
WhatsApped me. I was doing something else. So how are you doing?
Good. Final lectures.
So I think everyone who's
Yeah.
here today, let's have a small discussion because this is the final session. But what I thought is that we will call them, Dr. Logi, maybe
Yeah.
next week or week after, when the
Yeah.
certificates are ready, for them to come
Yeah.
and collect the certificates,
Yeah.
and for you to do a small, maybe a 1 hour presentation on the latest
Something.
developments.
Yeah.
We will invite some of the potential participants for the next program.
Yeah.
And also, now we are trying to finalize the MSc program.
Okay.
Okay, so postgraduate and MSc program, we are trying with two, sorry, two universities in UK and
Wonderful.
Ireland. Usually universities take little time to approve. So we are
Yeah.
pressing them to get the approval as quickly as possible. Once it is done, we will be
Good.
launching. And if you all are interested, you can join that program. So that
Yeah.
will be for 1 year and 3 months, 15 months, 9 modules, um, 9 modules and a thesis. So
Mm.
which is, we named it as artificial intelligence and information systems.
Mhm.
So hopefully when we get the approval, of course, Dr. Logi will be one of the resource persons. and we will
Of
have
course.
we will have a leading resource person, I would say, and we will have a very good panel of lectures. I think Dr. Logi will invite one or two from University of Moratu, and then we have got about 3 lecturers from University of Peradeniya. So it will be a combination of maybe 6 lecturers who are really into AI and good in AI. So that can create, I mean, that's a value addition that we can.
Yeah, sorry, like I have to leave. I have an appointment.
All right.
So,
Okay.
yeah, we will
Fine. Thank you
talk.
very much.
You can,
And
you can
I will
talk to
organize.
the-
I will
yeah.
organize this and let you know. Okay.
Yes,
All
Parag.
right. Okay.
Okay,
All right.
thank you.
Thank you. Yeah.
You can continue. You can continue.
Yeah. It is only for 2-3 minutes. I will talk to them. So Malindu, Amila, Madhushan, Hasiru, and Suranga. So we'll let you know the next session when the certificates are ready, and of course the future programs, what we are planning to do. All right. So you have any other questions that I am happy to answer. So also, how did you find this program? Was it helpful, and was it has given some value to you, and you were able to learn something from the program? So let us know also your feedback, because then we can improve the program. When we do the next session, so we can kind of improve the program. And also when we do the next session, if you want to attend the program, you can do it. You don't need to pay anything, so it's free of charge for you to attend the sessions, perhaps online. We do it physically, but we will have an online link that you can attend the program as much as you want. Okay. And also you have the access to the platform, so we can keep it for a period of time, so you can use it for practicing it. All right. Thank you. If you don't have any questions, then I will wind off, and then we'll meet. I'll
Mr.
let you know.
Barackam.
Yeah.
Mr. Barackam, thank you for your support, and Dr. Logi, because myself and my son, he also learned a lot of things as a young generation, and also I got the many knowledge to apply in the public sector, because we are representing public sector. As I get the knowledge from this training program, I think as policymakers we can do something for our country and to promote AI application. And meantime, my son, he's some kind of a technical guy. Then he will have interest to do more. He has interest on learning more deeply about the AI. So thank you for your team, and Dr. Logi, you and your team. Thank you for everything. Thank you.
Yeah, thank you. In fact, we have now I have a collaboration with the University of Peradeniya AI Research Center. Actually, the head of that AI Research Center is Professor Janaka Ekanayaka. He is a classmate of mine. So he is one of the lecturers will be doing the MSc program. Actually, he is the one who designed the program, so we have started a program called Young Techies AI Lab, that is for children to learn AI by doing practically. Because the Professor Janaka Ekanayaka's idea was that, like a language, if you teach AI to younger generation from grade 8 to 12, so they will pick up things quickly. So for that, if you do lectures like what we are doing for adults, so it may not be useful. So what we have done is we set up laboratory. So now we did 2 workshops in Kandy, so which we are trying to do it across the Sri Lanka, but that actually not a financially viable model, because we put 4 instructors. When you have children, group of children, 25 children, 6 each. So we put 4 instructors to do that because it's a close kind of a supervision. So we are trying to find a sponsor for this to take it across Sri Lanka. That's Professor Janaka Ekanak has designed 5 sessions like this. So like, developing a model. Now, for example, the first workshop we did that measuring of internal resistance of a battery. So we created a circuit board. So we manually do the measurements with using multimeters and then put IoT sensors and capture the data and then build a neural network, write a Python program, building a neural network, and then compare the readings of both the manual and the AI model. So then we are trying to now set up a traffic light system like what Logi has explained. So that is a practical traffic light system. And how do we, using IoT sensors, how do you control that? And then the face recognition system, we set up cameras and capture. So this is a kind of workshop that hands-on. So we will let you know. I mean, you all can, whenever it is in Colombo, you all can join, and you don't need to pay for it. I mean, you can just join it and see that these are for children, but of course you can come as observers. Okay. I think that's it from my side. So if you don't have anything, we can leave now. And since the group is there, I'll post the next events and the next program, and of course the certificate awarding ceremony in the group, so you can attend accordingly. All right, thank you. Bye.
Thank you, Mr. Parakram. See you.
Bye. So if there is anything, you let us know. I mean, if you need any, if you are doing further studies, even if it's other place, so you want to connect with the Dr. Logi or even Professor Janaka Ekanak has a good team. They are all good AI researchers. So I can connect with them if you are having interest of doing further studies. Okay. Thank you and all the best.